All right, this is Mr. Crozier, and I'm going to go over our practice test. Problem number 1. On this interval from -5 to 1, is there a 30? Well, we're going from 7 to 40. Well, obviously we're going to pass 30. We can't go from 7 to 40 without passing 30. That's called the intermediate value theorem. Number 2, I'm going to take this 6, divide it by this 2 right there, and that's going to give me all of my possible rational zeros there. So I have the factors of 6, which are listed here, the factors of 2, which are listed there, and then all the possibilities. 1 over 1, 1 over 2, 2 over 1, 2 over 2, 3 over 1, 3 over 2, 6 over 1, 6 over 2. And out of all of them, if I check them with my calculator, that's the only one that works. Number 3 is a downward-facing even function. So it could look like that. It's going to negative infinity on both sides. The roots here are at -2 and +2, but -2 is a single root because it goes through, and +2 is a double root because it goes this way. All right, number 8, finding the zeros. Factor out an x, and then we can take this and factor it by grouping, and then we have x is -1/4 and -3/2. On this one, same thing. I'm going to factor by grouping, but then x plus 9, if x squared plus 9 was 0, I'd have x is -9, which leads me to 3, but with an I there for the negative root. Letter C will require the quadratic formula. I have a table of a polynomial. I find the first differences, second differences, the third differences are even, which means this function would be written as f of x, some value of a, x to the third. And on number 7, we have a root of 3, so that's the 3 root right there. And then we have a 2i and a -2i. Foil them together. Then we're going to figure out a by plugging in 2 there and 1 there, and divide and multiply it through. All right, number 8, the leading coefficient. We have a first degree, second degree, and something. And I know it's 7, so it's first 1 plus 2 plus a is 7. A must be 4. This is a fourth degree. So it's a fourth degree, and what are the terms now? That's my degree. There's a 4 right there. But the question is, what are the terms? Well, I have leading terms. I have an x, then a 3x, but the 3x gets squared. Then I have a 2x, but 2x is to the 4th power. So we can go x, 9x squared, 16x, and multiply them together. The in behavior here, if I multiply this one and this one, I get 5x to the 5th, so it's going up. Down over here, up over there. Well, they're going together. It's an even negative. It's related to this graph right there if you want to know the most basic version. So it's a relationship to that. This function right here, does it have a global maximum or a minimum? Well, again, it's a fourth degree upside down. Well, in this case, it does have a max. There's a top to this, but there is no minimum because these go down forever. So there is no minimum value. There's a maximum, but no minimum. You can get this on your calculator. You can just graph this and then trace it, and what you'll find out is that the vertex is at 50 seconds, 127 meters. It's a calculator problem. Just graph it on your calculator and trace it. The vertex here. If I look at these two terms, if I take 8, which is my b value, divide it by 2 is 4. 4 squared is 16. If I add 16 and subtract 16, it's still a balanced equation. Then I can factor this and subtract that. And my vertex is a -4, makes that 0, and it's up 4. Same thing here, just be careful. When you add 4, you are really adding 2 times 4. So you're really adding 8 to the problem. Long division. I think we've done a lot of long division. We go ahead and take this, divide it all out. No, this is not a factor. X plus 3 does not divide evenly in there. We have a remainder there. On this one, I multiplied these two. Be careful, a lot of people put 9 there. It's not 9. Root 3 times root 3 is 3, and it would be minus 3i squared, and I squared makes it positive. 17, another problem where we know that this is a root. So since this is a root, x plus 5 divides in there evenly. I divided this evenly, no remainder, so now I just have this quadratic. I can take this quadratic here and put it right there, and then factor it by grouping. Zeros here, here, and it's falling to negative infinity on that side. We did one of these problems before where you FOIL it, get down to here, figure out what a is, and then multiply the a through. In this one, like before, we're looking for differences. The second row are the same. On 21, again, we're going to have the 8 factors of 8 on top divided by the factors of 4 on the bottom. And we have all those possibilities. And this one's interesting. None of them work. None of those work in here. All right, on the binomial theorem, remember you do your a values. This is a, and you count down from 4, a to the 4th, 3rd, 2nd, 1st, 0. These are your b values. B values count up, 0, 1, 2, 3, 4. And then you got to get your coefficients. Your coefficients come from Pascal's triangle. It comes from this row right here. And then we just multiply. If you multiply all of these, I'll show you on the calculator. If you multiply all of these, we have 2 to the 4th times 3 to the 0 times 1. That's going to give you that coefficient. For my second coefficient, I'm going to have 2 to the 3rd times 3 to the 1st times 4. And then my next coefficient, I'm going to have 2 to the 2nd times 3 to the 2nd times 6. And you just find the coefficients. Same thing on this one. Be careful. When you have this negative in here, the signs are going to go back and forth. Negative, positive, negative, positive, negative, positive. Because of these right here. If you have negative 2 squared, it's a positive number. But negative 1 squared is a positive number, but negative 1 to the 3rd is a negative number. All right, on the last page, the maximum number of turning points, if it's 4th degree, it has 1, 2, 3, 4 directions, but 4 directions only means I have 3 changes of turning points. I factored out the 2x, then I factored this just by guessing and checking, have my roots. 0 is a double root, the other ones are single roots. Multiplicity. Let's see here. We have zeros at 2, multiplicity of 1, that means it's going to go through. 3, multiplicity of 2, that means it's going to touch it and go up. And as we go to infinity here on the inputs, the outputs go to infinity. So it's going to look like that. Single root, double root, single root. And in this problem, we don't have a point to figure out what a is, so I'm just going to say a is 1. And then it's just going to be the same. And finally, long division. I did this long division, and I got 4, which means my answer is the x cubed plus 2x squared plus 3x plus 4 plus a remainder of 4 has been divided by 2x minus 3. All right, hope this helps with your test this week.